Assalamualaikum and hello everyone. Welcome to a new video of intermolecular force. In this video, what we're going to learn is actually plain factors that influence the strength of van der Waals force. Okay. In previous video, I have mentioned in detail about our van der Waals forces, which is our London force and our dipole force. So on your notes on page 38, we're going to learn what is the factor affecting strength of van der Waals force. Because for the intermolecular forces ni, what we're going to learn, mostly the question will ask in terms of boiling point. So here, the stronger the intermolecular force, the higher the boiling point. Okay, so why do I mention here? Because from the boiling point, then we can see lah tangible result. Is it stronger or weaker when comparing different molecules? Okay, so here. Kat sini lah, the stronger the intermolecular forces, the higher the boiling point. Okay, so we have learned about our van der Waals force. Kita dah belajar, which is our London force and our dipole force. London force is for all atoms and molecule, which is for our polar and non-polar. Whereas our dipole force is only applicable for polar molecule. Okay, so that is what we have learned in previous video. So sekarang ni kita nak tengok factors affecting the strength of van der Waals. Okay, so senang nak ingat dia adalah SSP. So what is SSP? Size, shape and polarity. Okay, so for the size, so let's look here. So this is a noble gas example. So this is down group 18 lah. Noble gases is actually group 18. So, as we can see here, down the group, dia punya boiling point, down the group, it will be getting higher. Okay, so why? Macam higher ni means sebab kalau negatif, so maknanya, okay. So, contoh kalau kita buat line kan. So, first ni helium negative 269. So, here is our 0. So, yang ni jadi negative 246. So, ni negative 186. So, walaupun if it's negative, so kita tahulah sebenarnya, sebab dia negatif ni sebenarnya kalau down the group, kita punya boiling point will be getting higher. Okay, so why? Okay, so what does it mean? So maknanya, down the group, it will have this, it will have a stronger intermolecular force. That's why down the group, we will have a higher boiling point. Okay, so why does it work that way? Sebab down the group, the number of the electron will increase ataupun kita punya molar mass will increase. So, and then we know down the group, kan down the group and sus kan. So, down the group, the number of shell, principal quantum number dia increase, shielding fact increase, attraction between the valence and the nucleus decrease. Hence, the size of the atom will be getting bigger down the group. So, what will happen here? The atomic radius will increase. Okay, and the strength of intermolecular force ni akan increase. Okay, and more energy atau heat is needed to overcome these forces. And then, it will have a higher boiling point. Okay, so contohnya kita punya helium dekat sini, I'm just gonna write down dia punya molar mass dia 4. Dekat sini molar mass krypton tadi apa? 83.8 kan. Okay, so for example, this is my helium. This is my krypton. Okay, so what happens is that, so bila kita tengok dekat sini kan, helium, the number of electron tu sikit sahaja. And the atomic radius pun kecil sahaja. So what would happen is that dia punya London force tu is weaker lah compared to a bigger size atom. Krypton ni lagi besar kan, it has a higher number of electron ataupun the higher molar mass. Sebenarnya dekat sini, the structure ni, so here is the symbol. This is what does it mean? It's actually a partial. So dekat sini, the diagram is incomplete lagi because remember that for temporary dipole ataupun kita punya London force ni, we have to show lah. Contohnya dekat sini, ni partial positive, it means that the side where there is less electron. Partial negative ni where the electron is concentrated on. So in this case around, so bila kita compare, this is our kita ni helium kan. Okay, so helium ni, so first side ni, yang ini ada macam kita bayangkan 1, 2, 3. Here 1, 2, 3, 4, 5, 6. So kiranya dekat sini yang akan jadi partial positif sebab the less electron ni partial negative. So because this is actually about attraction between the molecule kan. So kat sini kan adalah partial positif, partial negative. So sama lah juga yang ini. Partial ni is not complete yet. So ni partial positif, ni negatif, positif, negative. So please add in your notes. Itu sahaja. So what will happen is that the attraction between our krypton ni is greater than the attraction between our helium. So dalam kes ni sebenarnya senang nak tengok in terms of our molar mass lah. So this is actually for the case of element down group 18. So contohnya kalau usually we're gonna look for the case of organic molecule. So kita tengok dekat sini. First we have our CH4, our methane. The molar mass is 16. And then as we can see the boiling point is 112.15. Whereas our butane ni, carbon 4H10, molar mass dia 58. So macam mana dapat molar mass ni? Ingat carbon is actually 12, hydrogen 1. So yang ni 12 plus 4 jadi 16. Ni 4 times 12, 48 plus 10 jadilah 58. And then as we can see our C4H10 ni, the boiling point dia is higher. So yang ni pun sama juga, where this case kita tengok memang bila size dia is bigger, when size is bigger, then the boiling point increase. The same goes for our case of our methane and butane. So for the case of comparing, how do we going to compare it? First, we're going to mention about the molar mass of our C4H10 is higher than our CH4. So what would happen is that the strength of intermolecular force in our C4H10 is stronger. Okay, so bila dia punya force so strong, contohnya kita nak boiling point ni, maknanya we want to break the bond between the molecules itself. So what would happen is that kalau contohnya the attraction between the bond too strong, maknanya we need more energy lah untuk to break the bond. Okay, so kat sini more energy is needed to overcome the forces. So that's why kita punya C4H10 has higher boiling point than our CH4. Okay, so question dia selalu case ni for a given molecule, what we're going to do is actually first thing first, sebelum apa-apa kita nak compare in terms of size dulu. Usually in terms of size tu kita dah boleh tahulah, the higher the size ataupun the higher the molar mass. Sebenarnya size ni we're talking about our molar mass lah. Senang kita tahu dia adalah molar mass. Then it will have a higher boiling point. Stronger intermolecular force, hence higher boiling point. Okay, so next factor that we're going to look at is actually shape. Okay, so first kita dah tengok size, second is shape. So kita tengok dekat sini. Okay, so for the shape tu sebenarnya it is easier for you kalau tengok the number of carbon. Sebab contoh kat sini kita tengok carbon dia 1, 2, 3, 4. So carbon dia 4. Hydrogen dia will be 3, 2, 2, 3. It's H10. Okay, yang ni pun carbon dia 1, 2, 3, 4. So carbon 4 sebab and then hydrogen dia 3, 1, 3, 3. So C4H10. Okay, so from here, okay, previously we were talking about when the size is different, when the size is higher, then the boiling point is higher lah sebab it has a stronger intermolecular force. Tapi in this case, the molar mass is the same, but then the boiling point is different. Even though it differs slightly, but then it's still different kan? Okay, why? This is actually because it is based upon our shape. Okay, so dekat sini kita tengok. For this case, our shape is this one. This is actually our butane. Yang ini structure 1. This is our structure 2. Okay, so dekat sini kita tengok surface area for our butane ni is high, whereas kalau surface area yang sini is low. Okay, kenapa? So kita tengok balik dekat sini. Okay, it mentioned here is that the linear molecule can develop bigger temporary temporary dipole than branch molecule, and the linear molecule will lie closer together, which allows greater contact. So bila it's getting closer to each other, has a greater contact, so maknanya the attraction tu is very high. Sebab banyak kan, here greater surface area ni, greater contact tu, so it means that our attraction tu is high. So when the attraction is high, this will give rise to a greater London force. Okay, if we compare for the case of branch molecule, okay, yang area of contact tu, we're going to look at, contohnya yang ni lah, area of contact ni. For linear molecule, we have quite a lot if compared to yang kalau branch molecule yang kecil yang ini sahaja. Okay, so why linear molecule ni will have a bigger temporary dipole? Sebab dia closer together lah. So when we compare it, when when we're going to explain in terms of shape, kalau linear molecule ni, what we're going to have higher total surface area, hence a stronger London force. Whereas kalau branch molecule, we have a lower total surface area and we have a weaker London force. Okay. So, sebenarnya for the case of our molecule here, this is actually the structure. So, the first one, kita punya butane ni is a linear molecule. So, surface area dia is quite high. So, that's why it has a stronger London force. Okay, kalau kita punya the second one ni, is actually our methylpropane ni, tu methylpropane kita. So, dekat sini, it is not a linear shape. It's a branch molecule. Guna yellow lah. It's a branch molecule. So, dia punya surface area chinonate ni je. It's very small. So, that's why lower total surface area of contact, hence weaker London force. That's why when we're comparing the boiling point, this is our branch molecule. Branch ni is weaker than our linear molecule. Okay, so that is the second factor. The size and the shape. For the size and shape ni, we're usually talking about our London force, our non-polar molecule. Okay, last but not least, kita akan tengok in terms of polarity. Polarity ni kita akan tengok in terms of apa ni? Kalau similar, sama juga dengan shape, similar molar mass. We have our CH3, we have our ethane, dengan we have our CH3F. Okay, tapi molar mass dia, molar mass dia, it's quite similar, tapi sebenarnya, kalau yang ini, CH3 ni is a linear shape tau. CH3F kita ni pun sama juga. So, it's actually linear shape juga. Okay, tapi kali ni, what is the difference is actually polarity. CH3 ni, our ethane ni, is actually a non-polar molecule. While CH3F ni is a polar molecule. Okay, kalau polar molecule ni, okay, for the case of polar molecule, so how we're going to compare it? Kalau size kita kata, the higher the size, the stronger the intermolecular shape, the stronger the intermolecular force. Kalau shape, kalau the linear has a stronger intermolecular force. Kalau in terms of polarity dengan in terms of polar dengan non-polar, how we're going to mention it? Okay. Our ethane ni, CH3 is a non-polar molecule. Kalau non-polar molecule ni only has kita punya London force. Kita punya CH3F is a polar molecule. Kalau polar molecule, dia pun ada London force. But it has one extra force lagi, which is our dipole force. London force is for polar dengan non-polar, tapi kalau polar molecule untuk untuk polar molecule sahaja, it has dipole force. Okay. So actually, sekarang ni our London force ni is temporary dipole. Inilah dia temporary dipole, dia sekejap sahaja. Tapi kalau kita punya dipole force is permanent dipole. So dipole ni yang kita nak, sebab when we talking about dipole ni, we have two pole kan, maknanya kita ada positive pole dengan negative pole. When we have our positive dengan negative ni, barulah attraction kita ada, barulah ada force tu kan. So that's why actually for the case of dipole and London force, sebenarnya dipole force is stronger than our London force. So, kita tulislah dekat sini. Bila dipole force is stronger than London force, then more energy is needed to overcome the dipole force. Hence, kita punya CH3F ni has a higher boiling point than our CH3CH3. Sebab, ingat, CH3F ni ada dipole dengan London. Tapi yang CH3CH3 ni ada London sahaja. Tapi kita compare, CH3F ni yang lagi higher. Why it has a higher boiling point? Sebab dia ada extra yang dipole force ni. And then the dipole force is stronger than London force. Okay. So, yang kat tepi ni just nak buat summary. In terms of comparison, kita akan tengok pada ni lah. Size, shape, polarity. Kalau size ni, kita akan tengok pada kita punya molar mass. Kita punya boiling point pun akan jadi higher. So, next is actually in terms of shape. Okay, kalau shape ni, kita tengok molar mass dia is the same. Kita nak yang linear. So, kalau linear, barulah boiling point tinggi. And then, in terms of polarity, dipole force stronger than our London force. So, no worries kat sini. Nanti misalkan bagi lagi banyak lagi latihan dekat Google Form. So, just for you to be familiar. What is actually the factors affecting the difference in the boiling points. So, that's it for this video.